Okay, ammonia. They've given us this reaction here. That's nitrogen plus hydrogen makes ammonia. This is the Haber process. It's how we make ammonia. And the reaction is reversible. This double arrow here means that nitrogen and hydrogen react to make ammonia, but the ammonia can decompose back into hydrogen and nitrogen. The reaction can go both ways. Not all reactions are like this. If the reaction arrow is just drawn like that, how you're used to, then it's only a one-way reaction. It can't go backwards. But the Haber process, it just happens to be a reaction that can go both ways. Okay, and they've told us that the forward reaction is exothermic, so the reverse reaction is endothermic. In that direction, it's exothermic. Okay? That means when nitrogen and hydrogen react to make ammonia, heat is released into the environment. But in that direction, if it's exothermic in one direction, it has to be endothermic in the other. Okay? When the ammonia decomposes into nitrogen and hydrogen, it actually takes in heat from the environment. So just remember that reactions, if they're exothermic in one direction, they have to be endothermic in the other. So yeah, complete the sentence. The forward reaction is exothermic, so the reverse reaction is endothermic. Okay, calculate the percentage by mass of nitrogen in ammonia. Right, so they've told you the relative atomic masses, which they didn't have to do because they're in your formula sheet in the periodic table that you've got. If you look at your periodic table, the nitrogen insert bit looks like this. The 14 is the mass number. The 7 is the atomic number or the proton number. And it's the mass number that tells you the relative atomic mass. So they tell you that hydrogen, the relative atomic mass is 1, and for nitrogen it's 14. But like I say, you can find that out for yourself by looking at the formula sheet in the periodic table. Okay, calculate the percentage by mass of nitrogen in ammonia. So, ammonia is NH3. Okay? And they want the percentage by mass of the nitrogen out of the whole thing. So NH3 means there's one nitrogen atom and 3 hydrogen atoms. It looks like this. Nitrogen with 3 hydrogens bonded to it like that. That's an NH3 molecule. So, to work out the percentage by mass of nitrogen, you take the relative atomic mass of nitrogen, which is 14, okay, the big number at the top, and you divide by the relative atomic mass of the whole thing. The whole molecule is 14 plus 1 plus 1 plus 1, because hydrogen is 1. So the total is 14 plus 3, which is 17. Okay? And then to turn it into a percentage, you multiply by 100. So that's how you work out the percentage by mass of an atom in a whole molecule. Okay? Stick that in your calculator and it turns out to be 82.35%. 82.35%. That's too many decimal places. It's sensible to round it down to 82%. The 3 means it leaves that 2 alone. So there you go, 82%. This is normally written like so. You'll see it written like that more than you will like that. So the relative atomic mass is a big number at the top, and that's the proton number or atomic number. Okay, and hydrogen would be 1, 1, like so. That's where that 1 comes from. Anyway, let's move on. Give the pH of a neutral solution. Well, it's 7. If you have a solution that's neutral, the pH is 7. You've just got to remember that, okay? Neutral solutions have a pH of 7. If it's an acidic solution, the pH is 6 or below. If it's an alkali solution, the pH is 8 or above. Okay. Right, which of these ionic equations shows a neutralization reaction? Well, you need to know what defines a neutralization reaction. A neutralization reaction is one in which a proton, that's an H+, or a hydrogen ion, H+, same thing, reacts with hydroxide, that's an OH-, okay? So that's hydroxide, and that's, you can call it a proton. It is a proton, but in your exams they're probably more likely to refer to it as a hydrogen ion. Okay, an ion is a charged particle. It's an ion because it's H+, it has a +1 charge. Hydroxide is an ion as well because it's got a minus charge. So, back to the question, a neutralization reaction is one in which a hydrogen ion reacts with hydroxide ion to make a water molecule. That's the definition of a neutralization reaction, okay? So, the answer to the question is, it's this one, it's the first one. See, this one doesn't qualify, you're not making water. You're not making water here, you're not making water here. So none of those three count. I mean, they're trying to trick you. Well, not trick you, but they're trying to... You might be caught out by seeing an H+ there and thinking that it could be neutralization because neutralization involves acids. An acid is a solution with a load of H+ in it. So you might think that's neutralization, but it doesn't qualify because there's no hydroxide ion. Okay? And this one doesn't qualify, there's no hydroxide ion. This one doesn't qualify, there is a hydroxide ion, but there's no H+ ion. The H+ ion is, it's not there, that's ammonium, it's not H+. And it doesn't make water, so it doesn't qualify. Okay, let's move on. Name the salt produced when ammonia reacts with hydrochloric acid. Okay, so ammonia is NH3 and we're reacting it with hydrochloric acid, which is this reaction would normally be done with HCl in solution. That is hydrochloric acid. But I'm not going to write the water as part of this equation because it's a slight distraction. Anyway, what's the question again? Name the salt produced. Okay. So, what salt, when you react these two together, is going to be formed? Well, if it helps, you can write a little plus next to the H and a minus next to the Cl. HCl, whether it's in, well, when it's in solution, hydrochloric acid, the H+ is floating around by itself inside the solution, and so is the Cl-. They're not bonded together. That's when it's in water, in solution. But to answer this question, it's a slight distraction. I'll just tell you the answer. Just remember this, okay? When you mix HCl with ammonia, the salt formed is NH4 plus Cl minus. Okay, that's ammonium chloride. Ammonia is NH3, ammonium is NH4 plus, and NH4 plus Cl is ammonium chloride. Okay, the H plus goes onto the ammonia and the Cl minus is Cl minus. Yeah, okay. So just a little bit extra on ammonia in water. Ammonia is an alkali, which means it's soluble in water, and when you place it in water, it forms an alkali solution which, if you add acid, will perform a neutralization reaction. So how does ammonia do this? If you put ammonia in water, okay, what happens is it forms ammonium hydroxide. One of the hydrogens from the water goes onto the ammonia to form ammonium, okay, NH4 plus. Okay, it takes one of these hydrogens, leaving OH minus behind. Okay? And now we've got our hydroxide ion. Okay? So before adding acid, if you've just got pure water and you add ammonia, it will form ammonium hydroxide. And that is our alkali, because like we talked about, you need a hydrogen ion and a hydroxide for a neutralization reaction. So we've now got our NH4 plus, OH minus, our ammonium hydroxide in solution. If we add an acid to that, such as hydrochloric acid, we'll get a neutralization reaction, because we have OH minus ions floating around and H plus ions floating around. And those two get together, OHH, and form water. Okay? So those two reacting to make water is that bit. That's why it qualifies as a neutralization reaction. And what's left? NH4 plus and Cl minus. And that's the salt. Ammonium chloride. Okay? So, that's how ammonia works as an alkali. You mix it with water, it forms ammonium hydroxide, then you add the acid and you get the neutralization reaction. Okay? Ammonium hydroxide plus hydrochloric acid makes water and the salt, which is ammonium chloride. Okay, we've got another 6-mark essay question to do. I don't know about you, but I hate these questions. So let's just get through it. Right, we've got to extract 6 marks. And what you have to do is suggest the best amount of ammonium nitrate for the farmers to use per hectare. Okay, that is all the information they've given to you in the question. These 3 graphs and the fact that rainwater dissolves ammonium nitrate in the soil and some of the ammonium nitrate runs off into rivers and lakes. So you have to use this and your knowledge to get the 6 marks. So it's an essay question, so you do get some marks for writing nice sentences and arguing points and linking things together correctly. So you've got to try and do that in the answer. You can't just write bullet points down, for example. So, to get maximum marks, you need to say, you've got to draw some conclusion or write something about each one of the graphs they give you. Okay, so let's write down our knowledge. What do we already know? Well, what's the first thing I've written? Okay. Why do farmers use fertiliser like ammonium nitrate? So just write down. Okay, I'm going to write it as a bullet point, but you have to write it as a nice sentence in the exam. Fertiliser improves yield. Okay? So the more ammonium nitrate you use, the higher the yield. You should already know that, but it is proven in this graph they've given you. Okay? So, let's say something about this graph as well. Well, you could say that yield improves quickly up to a mass of ammonium nitrate per hectare of 200, but then it only increases slightly from 300 onwards. Just saying the obvious, like I keep banging on about in all these sort of questions, say the obvious, describe the obvious, and you'll probably get a mark for it. Okay? Right, what can we say about profit? Well, profit is at its highest at a mass of 200. So, to say something like, it's desirable for farmers to have as high a profit as possible, so 200 would be the best mass for the maximum profit. Okay. Right, this one, mass of ammonium nitrate running off into rivers and lakes. So again, just say the obvious, say that there's a low runoff up to a value of 300 and then it increases quickly. So what do you know about fertilizers running off into rivers and lakes? Do you know, I'll write it down here, I'll leave that. Have you heard of this word, eutrophication? Okay, well you have now. Remember it and use it with these sort of questions. Eutrophication is what happens when too much fertilizer runs off into rivers and lakes. It's when it leads to the oxygen being depleted in the water and for aquatic life dying because of low levels of oxygen. And that's clearly very bad for the environment. So say that in this essay, mini essay question. It's important to minimize the mass of ammonium nitrate running off into the rivers because of eutrophication, and it's harmful for the environment. So ideally, farmers should keep the mass of ammonium nitrate below 300 for a low runoff. Okay, you getting the ideas, the sort of thing you got to say? Right, what else can we say? Okay, so let's actually answer the question. Well, clearly, right, 200 is the obvious, probably the best number to suggest. So suggest 200 for these reasons. Firstly, you get maximum profit, so that's good for the farmer. Looking at this graph, yes, you do get a higher yield with masses above 200, but the gains are only slight. You still get a very good yield at 200. Okay? And at 200, the runoff is still very low, so that's good for the environment. Okay, I think if you can put all that in nice English prose, you should get 6 marks.